let's try to understand how we can basically scale the system. So there are multiple approaches. One is very obvious, is vertical scaling. As we talked, we just increase the configurations of the server, like increasing the RAM, CPU, its hard drive, all those comes under vertical scaling. So you keep on increasing the configuration, and this would basically add some resources to your overall system. But this works well for when there is an incremental increase in traffic. Let's say from x to your traffic is going to 1.2x. But if your traffic is going to 100x, definitely this is not a solution. You definitely have to go with horizontal scaling. You have to add more servers, you have to add more database clusters and whatnot. So as vertical scaling, every configuration increase has a limit. You cannot go infinitely in a single machine and like have like terabytes of RAM. So this is where like most of the organizations fit in, like big organizations like Amazon, Flipkart. They all are distributed and they are basically horizontal scalable. So when there is a need like big billion day where they're expecting more traffic, so what they do is like all their backend services, they keep on adding new nodes, and once that big billion day is over, they remove those nodes. So there is something called auto scaling as well, where if you have heard about AWS and other cloud providers, they automatically detect the increase in traffic, and they automatically add the new servers, and same they can decrement the servers if the load is decreasing. So this is a little bit advanced concept, but I just wanted to all to understand what horizontal scaling is. So when the system is called scalable, now let's come to the formal definition. A service is called said to be scalable if when we increase the resources in the system, it results in an increased performance on the manner, like very basic definitions, right? So these are very basic ways to scale up your system. Let's understand more in details what those mean, right? So scaling up the services, we already understand adding more hosts to the system, more nodes, which is basically horizontal scaling. Increase RAM of the boxes, which is nothing but vertical scaling. Scaling up the database, adding more database nodes, clusters, again it comes into horizontal scaling. No, these two, 3 and 4 are again very interesting, right? So you have an option to introduce cache into your system, because definitely all the data which your system needs won't be coming from database. So there would be some sort of static data which is not ever changing. So one of the way you can make your system more scalable is finding opportunities into your architecture where you can fit in the cache, so that every call with the user is making is not making a very expensive database call. So database calls are very expensive. Why? Because database reads are hard drive reads, so they are compute intensive operations. So what you should effectively do is identify opportunity in your system to have cache, and cache would be a separate topic we'll be discussing later, but just to give you very high level idea is whenever your data in the database is not changing, for example your user profiles or your blog post or something like that, so in that case you can basically cache that data into your distributed cache. So instead of your request going to your database every time, you have cache in between, which will basically return you the response, and you could save like expensive CPU cycles. So let's say you have your application server, and then you have a database. So in between, what you do is you put a cache, right? So you put a cache in between. So instead it will go to cache, and if not found, it will go to database. And if it found a database, it will update on the cache as well. So that's why that is also one of the way every um, scalable system has that concept of caching. This is not just helps you in to scale up your system, also reduce the latency. So database calls, the cache calls are usually an order of 1 millisecond, where these calls, database call goes from 15 millisecond to 20 millisecond. Again, depends on the configuration, the database you choose, and what type of replication or the strategy you are choosing. So this is one of the way you make your system more scalable, right? Introducing caches. Now there is one more opportunity into your system, how you can like decouple the load from external traffic of your system. That is introducing queues, right? So there is a lot of non-critical work as well, which you have to do in your system, like which is which can be done in a async manner, and it doesn't matter like if the response is delayed by certain millisecond or certain seconds or minutes. For example, sending an invoice or sending an order confirmation, it is fine that it is your confirmation is email is sent being after like 2 seconds, 3 seconds, even after your order is complete, right? So this type of non-critical task you can offload to queue, right? So what does the how does the architecture look like is that you have uh, something called queue. This is maybe the examples are Kafka, or you have RabbitMQ, and then you have a consumer return, which is polling the messages and sending emails or doing other stuff, right? So let's say now your traffic is 100 requests per second, so you are sending 100 messages, right? So maybe consumer is taking some time and they're sending emails in 2 seconds, right? And with a delay of 2 seconds. Now your request increased from to 10k per second. So what will happen is your queue is there to decouple the load. So instead of like 100 messages, it will have 10k messages per second. And then your consumer, uh, instead of sending the messages, even if it takes the same polling rate, the polling rate is basically the number of messages it consumes, right, in a second or some unit amount of time. So even if the polling rate is same, so and we are not scaling any hardware, instead of sending it in 2 seconds, it might take 20 seconds or 200 seconds. So from the business point of view, this is fine, this is permissible. So what we have done is like we have decoupled the external load by using a queue, and we are not nowhere scaling our internal systems. So even if this goes to 100k, we are fine, because uh, we are just accumulating more messages, and we are just sending the responses in some delay, but we don't want to spend so much money in scaling our system for these type of non-critical sort of work. So that's where asynchronous processing also comes into picture. This is where you can easily leverage queues and other messaging systems, and this also makes some sort of this also makes your system more scalable. Cool. So these are basic approaches you can take to make your system more scalable. Definitely, there are a lot of other bottlenecks as well. As we go on to the course, we'll understand more about it. So this is what a one possible architecture looks like, where you have caches, where you have application code, you have database, which is again a cluster. You assume it as a cluster. You let's say a request is coming to you. You first read into the cache. If If the data is not available, you go to a database, right? And then if there is some change in the database, there is application code which updates the cache. You put some sort of asynchronous messages into the queue, asynchronous tasks in the queue, then this behaves independently. So even if your traffic is increasing, you don't have to scale this up. um, you have caches to avoid costly database calls. You have search queries going to a different microservice. So microservice is something we can also put into your system, but we will try to understand more about it in future lectures. But you could also think like delegating certain type of work to a certain microservice, and that's how like you can independently scale your overall system. Let's say your search query is somehow sometimes increasing, so in that case you don't have to scale up your database server. You can just scale up your microservice or any indexing which you have taken. So that's how like you could have different pieces, different components in your architecture, which you can independently scale, and that will eventually make your whole system scalable.